This is a light refraction problem, and we know when we are looking at object in water, it will appear closer than where it is due to the refraction. And if I take this to be real depth and this is apparent depth, and the relationship between the real depth and apparent depth is given by real depth over apparent depth is equal n1 over n2, where n1 is the refractive index of the medium where light travels first, and n2 is where light travels next. Okay, and then before coming to the actual problem, I'm going to do one example. I'm going to consider a fish tank. Okay, now I consider a fish tank. Rectangular fish tank, and I say this has 32 centimeter length, and let's consider there's a fish of length 12 centimeter. Real length is 12 centimeter of this fish. So, and then we consider the distance to this tail to here to be like around this distance to be like around 16 centimeter. So 16, 12, 28, therefore this is going to be 4 centimeter. Okay, so now I'm going to look at the fish from this side of the this tank. Okay, so here when we are looking at the fish, we know due to the refraction it will appear not in the exact place. So here now I'm going to consider the head of the fish, or you can say mouth. Okay, I'm going to consider head, and I'm going to use this relationship. So that is real depth over apparent depth equals n1 over n2. Okay, so real depth we know to the head is 4 centimeter, and apparent depth we don't know. Let's take x1, and n1 is the refractive index of the medium where light travels first. So we are looking at the head of the fish, so light reaches from here to the eyes. So first medium is refractive index of the this water. I said water tank, so we know refractive index of water is 4 over 3, no? So that is 4 over 3, and n2 let's take AR, it's 1, therefore x1 is going to be x1 is equal 3 centimeter. And so here head is appears somewhere here, not actually at 4 centimeter depth but at 3 centimeter depth. And similarly now I can find the apparent depth to the tail. So I can use again that length depth to the tail is 16 centimeter. I'm using this equation over, I don't know where the tail appears, I take x2, that is going to be then n1 is 4 over 3 times over n2 is 1. So simplify this, I get x2 is equal 12 centimeter. Therefore the apparent length of the fish I can write x2 minus x1, because the tail appears somewhere around 12 centimeter and head appears somewhere around 3 centimeter. Therefore apparent length of the fish is going to be x2 minus x1, then that is equal 12 centimeter minus 3 centimeter. So apparent length of the fish is 9 centimeter. Okay, and then now I'm going to look at the fish from this side. Okay, so now again I can consider the distance to the head. So I can use this equation. So the real depth is 16 plus 12, 20, 26, 28 centimeter over, I don't know where it's going to be appear, so I take y1, that is equal n1 over n2. So n1 is 4 over 3 and n2 is 1, like reaches to this side. Yeah, so y1, we get y1 is equal 28 divided by 4, 7 into 3, 21 centimeter. And similarly, now I can find the apparent depth to the tail. So that is, real depth is 16 centimeter over, I don't know where it's going to be appear, I take that is y2, 4 over 3 over 1. So y2 is equal 12 centimeter. Therefore I can write the apparent depth of the fish when we are looking at this side. That's going to be y1 minus y2, that is 21 centimeter minus 12 centimeter, so that is equal 9 centimeter. So now we can see, if you are looking at this side or this side, from either side the apparent length of the fish is going to be 9 centimeter. And here I can use a short method. So that is, I can write real length over apparent length is equal n1 over n2. So real length is, we know real length of the fish is 12 centimeter over apparent length, I don't know, let's say L. So n1 is 4 over 3 times over n2 is 1. Therefore apparent length is going to be 9 centimeter. So this is a short method. So now we know from looking at either side the apparent length is going to be the same, it's 9 centimeter. Okay, this part I discussed just for the additional knowledge. Now let's come to the actual problem. Okay, so here we have our glass cube, and the length of the glass cube is given 24 centimeter, and let's consider that the air bubble is somewhere here. So I don't know the real length to this air bubble, so I take this to be the length x. So if this is x, we know air bubble is very small, it says small bubble, therefore this length is going to be 24 minus x. Okay, now I can use when we looking at this side, I can use the real depth over apparent depth, that relationship. Again I'll write real depth over apparent depth, that's equal n1 over n2. So real depth is, I don't know, x, and it says apparent depth is 12 centimeter. So n1 is given 1.5 of glass cube, so 1.5 over AR is 1. So x is equal, I can write 1.5 is 3 over 2 times 12 centimeter, therefore x is equal 18 centimeter. That means the air bubble is 18 centimeter away from this side. So if this is 18 centimeter, so this length is going to be 24 minus 18, that is going to be 6 centimeter. So now I can use this relationship when we are looking at this side. So that is going to be, real depth is now 24 minus x, that is 6 centimeter, real depth is 6 centimeter over, I don't know where it's going to be appear, apparent depth, that's what we want to find. Let's take it as y, and here n1 1.5 over n2 is 1. So I can write y is equal 6, y is equal 6 divided by 1.5, that means 2/3. So y is equal 4 centimeter. So the answer is 4 centimeter.